welcome to Jinghua Education. I'm Steven. In this video, we're going to talk about Calculus 1, Limited Tutorial Part 14, Continuity, and then how to determine the function is continuous or not. Some question even ask you, is if these equations or these functions it continue everywhere? Okay, how do we answer these kind of questions? Alright, so before we do that, let's think about what is continue. So many students is very confused about what is continue. Okay, on the textbook, they will show you like a lot of rules and theorems, a condition again, and then to show you what is like very elegant, very well-written mathematical languages, and then it's not make sense. I'm going to translate those knowledge into a very simple, understandable languages for you. All right, so what is continue? Continue, just continue. This is continue. That is not continue. That's easy. However, the real world question is not that easy, right? So the question they always ask you is this function continue at this point, at A? Okay? So in order to prove it continues, we need one conditions. Requires three things in these conditions. What is three things here? So it's the limited when x approaching to A, negative, and then limited x approaching to A, positive, and then f A. These three things must be identical. If they are identical, they are continue. If they are not identical, they are not continue. That easy. Okay, so what's the actually engine? What's the reason of this? Okay, from left hand side, right hand side, and then the entire point. If these three things meeting at one point, that means it's sealed, and then it's continued. If any one of them is missed, it's not continue at all. Make sense? Okay, before we're using these two together to show what? To show limited exist, right? If A negative, A positive are pointing to the same value, that means the limited x approaching to A exists. We can also say if the limited at A exists, and then also fa exists, and the fa equal to limited x approaching to A, that is continue. Okay, so if you understand these things, good. You don't understand these things, forgot what I've said, forgot what I said. Okay, just remember this: limited A negative, limited A x positive, fa must be exactly the same. Then we prove it's continue. Okay, so far we have learned all the functions, like linear function, quadratic functions, exponential function, logarithm function, trigonometries, almost everywhere. Every single functions is continuous function. Okay, one is not a function, not a continuous is tangent functions, secant functions, cotangent, cosecant, and the reciprocal functions. Okay, so we don't talk about these things for now. All right, let's see these questions. So I will ask these questions. Is these functions continue everywhere? Okay, let's see. This is conditional function. Actually, there are two parts. Okay, one part is what? In this part, that is quadratic functions. Quadratic function is always continue. It's already proved. You don't have to prove it. Okay, you just can use this fact. The quadratic function is continue. This is what? That's a linear function. Linear function is also continue. That means it's less than -2. That means we got a -2 here. Okay? Everywhere before -2 and then everywhere after -2 is always continue. Okay, if the question asks you, is this continue everywhere, the only possible suspect, only candidate to make this entire thing discontinue is at xt equal to -2 part. Okay, now we're going to prove, is this function continue at t equal to -2? How to prove that? Limited t goes to -2 negative at ht. Okay, limited t goes to -2 positive ht, and then h -2. We need to find out how much this thing is, and then to see if they are actually same or not. Okay, how do we prove this? -2 negative is a little bit less than -2, right? Less than -2, that means in here, that means we put in -2 in here, which is got +4. Okay, bigger than 2, which is in here. Negative 2 plus 6, positive 4. Equal to 2, equal to negative 2, equal to, we put in the same positions, which is 4. So 4 equal to 4 equal to 4. So this function is continued at t equal to negative 2. Okay? So the three things are equal is only proves is continued at that point. Is it continued elsewhere? You need to test entire things again in the elsewhere. But in these questions, we have already tested. Okay, in the before negative 2 is continued because quadratic functions. After negative 2 is continued because it's linear functions. All right. So once we done these things, we proved this function is continued everywhere. Okay, I hope you understand. If you have any questions, just comment below. I will answer your question in my next videos. If you like, please subscribe. Thank you for watching.